All right, let's do one last example here. A spherical balloon is being inflated. Determine the rate of change of the volume with respect to the radius when the radius is 10 centimeters. Once again, we can tell, based on the way it's stated, that this is instantaneous. So, in this case, I'm dealing with the change in the volume divided by the change in the radius. Because it's instantaneous, I'm going to state that the limit as h approaches 0 of f of h plus 10 minus f of 10 divided by h, because we're looking for this at the radius value of 10. Now we're going to use this formula to sub in for the f of h plus 10 and f of 10. So we're going to say that this is equal to the limit as h approaches 0 of 4/3 times pi times h plus 10 cubed minus 4/3 times pi times 10 cubed all over h. First thing I'm going to do is I'm going to remove the common factor of 4/3 and pi from both parts. And I'm going to get the limit as h approaches 0 of 4/3 times pi times h plus 10 cubed minus 10 cubed all divided by h. And at this point, we just have a difference of cubes. Remembering from when we covered the first section, the difference of cubes was where we had x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. So that means that when we factor that, we get the limit as h approaches 0 of 4/3 pi. The cube root of the first part is h plus 10, and the cube root of the second part is 10. And that leaves us with h plus 10 squared plus h plus 10 times 10 plus 10 squared. And this is all over h. Well, the easiest part here, obviously, is the h plus 10 minus 10 is just going to give me h. When I expand out this numerator, I'm going to get h squared plus 20h plus 100 plus 10h plus 100 plus 100. I can also remove that common factor of h. Remember, we always have a common factor of h if we do this properly to remove from this equation. And that means that the limit as h approaches 0 is going to be 4/3 pi times, when I combine the h squared plus 20h plus 100, so on and so forth, I get h squared plus 30h plus 300. So my change in volume divided by my change in radius is 4/3 pi times 0 squared plus 30 times 0 plus 300, which is just going to leave me with 400 pi, and the units are centimeters cubed per centimeter. And that's it.